Today we will talk about similar polygons. Similar polygons is an extension, a continuation of our previous topic, congruent triangles. So we're still in the same unit as congruent triangles. Previously, when we said congruent meant same size and same shape. Similar is like that, but now similar, what we need is just the same shape. So it can be the same shape but different sizes. Before we check for similarity, there's two important concepts that we need to cover. One is ratio and the other is proportion. Ratio is a fraction that's expressed A over B. These represent sides of our shape. Another way to write ratio is as A colon B. We read this as A is to B. And you will see later down what we mean by ratio in terms of context. Next one is proportion. Proportion is when you have two or more ratios that are equal to each other. So we have A over B equals C over D. We say two shapes have a proportional size when this equation, this ratio equation works out. When your first ratio equals the second ratio. Now let's talk about the similar polygons. For two polygons to be similar, we said that they have to have the same shape. In order to check for the same shape, two criteria need to happen. One, that their corresponding angles are congruent. And two, that all corresponding sides are proportional. So what do we mean by corresponding sides are proportional? Let's show an example. Suppose we have two rectangles with these dimensions, these numbers on them. For them to be similar, we have to check if the sides are proportional. We do this by setting up fractions. There's two different ways we can set up that proportion. First way is I can stay within the same rectangle. Setting up my fraction, it doesn't matter which one goes first, big side or short side, you can pick. For here, I'm going to pick the short side. So 5 over 7 equals, now do the same for the matching rectangle. For the second rectangle, it's going to be 10 over 14. And you have to check, are these two fractions, ratios, equal to each other? So you can either type 5/7 in the calculator, see what decimal that comes out to be. Type 10 over 14 in the calculator and see what that decimal comes out to be. Another way to compare fractions is by cross-multiplying. Cross-multiplying. 7 times 10 gets me 70. 14 times 5 also gets me 70. Because both of them are 70, that means they're equal to each other. So yes, they are similar. And this squiggly line right here is the symbol for similar. The other way we can set up that proportion is by matching sides from one shape to the other. Again, let's start with the 5. The 5 on this rectangle, it's the short side, so it matches 10 on the other rectangle, the short side. 5 over 10 equals long side 7 over long side 14. Again, we check cross multiply. 10 times 7 is 70. 14 times 5 is 70. Since they're both 70, that means they're equal to each other. That means, yes, the fractions are equal. So yes, they are similar. In addition to checking for proportions, we also have this concept called scale factor. Scale factor. Scale factor, it's a number that tells you, going from your first shape to your second shape, how many times bigger is the second shape, or how much smaller is the second shape. That's called a scale factor. Scale factor can be found this way. Scale factor SF equals second over first. When going forward, we multiply, and when going backward, we divide. And you'll see in an example what do we mean by multiply and divide. Okay, using the same example from above. Again, we have my two rectangles. Just make a quick sketch. There's the 5, there's the 7. Slightly bigger rectangle. There's a 10, there's a 14. So, normally we just go from left to right, unless they tell us specifically which way we're going. Sometimes we'll do an arrow, sometimes we'll do descriptions like going from the larger rectangle to the smaller rectangle, or the other way around. For this one, let's just go from left to right. That means this is my first shape, this is my second shape. So scale factor, we said, is my second divided by my first. That means on my second, I'll pick a side. I'll pick 14. 14 matches 7 on the other rectangle. So it's going to be 14 divided by 7. As always with fraction, we want to simplify if we can. 14 divided by 7 is 2. That means scale factor is 2. In context, what this means is your first, going from the first rectangle to the second rectangle. This is 2 times bigger than this. Or, going from here to here, we're going backwards. It's smaller by a scale factor of 2. Or it's 1/2 the size. Scale factor is something we use when we're missing a side. So, 4, 8, 12x. If we're missing a side, this is where we use scale factor. So again, let's calculate scale factor. This time, let's still call this my first, this is my second. So scale factor, my second number, 12, divided by my first number, 4, gives me 3. That means this rectangle is 3 times bigger than this. So to find x, we start with the 8. Going from 8, we're starting on the first rectangle, moving on to x, the second rectangle. That means we're moving forward. So we multiply. 8 times your scale factor of 3 gets me 24. That means x equals 24. Alright, next I'll do an example where we're moving backward. Again, let's call this my first rectangle. This is my second rectangle. So scale factor. 21 goes with x. I don't know what x is, so let's not use that. I do see a 15 which goes with a 5, so we can use that. 15 divided by 5 gets me 3. That means my scale factor is 3. Now, we're going from 21, the second rectangle, to x, the first. We're moving backwards, which means we divide. 21 divided by scale factor of 3 gets me 7. So x equals 7. We can use scale factor to solve for that. Alright, last thing I want to do is this example. Check if these two figures are similar. Yes or no. So for similar, we need two criteria. That one, corresponding angles are congruent, and two, corresponding sides are proportional. So here we can match up angles. This angle with the one arc goes with that angle. This angle with this one over here. This angle goes to this angle. And this angle with that angle. So we do have 4 pairs of congruent angles. We're fine there. What we need to check are the proportional sides. So we need to set up proportions, ratios. I'm going to go ahead and pick my smallest side. For this quadrilateral on the left, my smallest side is 1. This 1 matches the 1.5 here because it's also the smallest side. And we need to check 1 over 1.5. Does that equal my second smallest side, 2, over second smallest side, 3? And check, does that equal my third side, 2.5, over my third side, 3.75, and last one, 2.6, the biggest side, over 3.9, the other biggest side. You need to check all 4 of them. If you were to type this into the calculator and tell the calculator to simplify your fractions, the calculator will tell you that 1 divided by 1.5 is the same as 2/3, and we already know that's 2/3. 2.5 divided by 3.75, that's also 2/3. And 2.6 divided by 3.9 is also 2/3. Because all of them equal 2/3, as a fraction, a simplified fraction, that means that yes, they are proportional. All my matching angles are congruent, corresponding angles are congruent, and my corresponding sides, they're all proportional, meaning they all have the same fraction. So there you have similar polygons and scale factor.